today to do some math with me, Mr. Sohn. And today we're going to be doing some cross multiplication. Let's get into it. So we're going to start off with an easier problem. We're going to do a cross multiplication problem that just has the basics. We're going to have an x over 7 is equal to 3 over 10. So if we have a cross multiplication problem like this, and we have to take the x and multiply across from it, which would be x times 10, and take the 7 and multiply what's across from that, which would be 3 times 7. So I always like to put kind of an x shape there. So that would be 10 times x, or x times 10 is 10x, is equal to 3 times 7, 21. So then all we have to do is do 10 and divide 10 on both sides, and we would get 21 divided by 10, which is 2.1. That's all there is to it. So we're going to do a few like scaled up problems as we move forward. The next problem will involve a little bit of distribution. So if we take something like this, where we have a 2x minus 3 over 5 is equal to a 3 over 10. It's going to be the same sort of problem where we have to multiply what's across from each other. So this 2x minus 3 is going to have to multiply with 10. And the 5 is going to have to multiply with the 3. So I'm going to put a 10 in front of the 2x minus 3 in parentheses. I'm going to have a 5 multiplied by 3 on the other side of the equal sign. Don't forget the equal sign. If you forget the equal sign, this is not going to go well. So we're going to distribute the 10, and we're going to multiply 5 and 3 together. So 10 times 2x is 20x. 10 times 3 is negative 30 because it's negative 3. And 5 times 3 is 15. We're going to add 30 to both sides. So we add 30, we add 30. We get 20x is equal to 45. And when we divide by 20, we get x is equal to 2.5. All right. Moving on, we're just going to keep adding a little extra element to make this equation part a little bit harder, but this overall process is not going to change, where you have to take what's multiplying here and multiply it with what's across from it. That's why I call it cross multiplication. So our next problem is going to also involve distribution. We are going to take an x plus 3 over 4, and it's going to be equal to an x minus 5 over 6. And I'm numbering them today, so that's number 3. So we're going to multiply across, so this x plus 3 is going to multiply by 6. I'm going to put the 6 in front of the x plus 3. And that is because it's easier to distribute with the 6 in front rather than the x plus 3 in front. So if there's ever multiple things, I always put that after the other number that we have here, like 6. Okay, so whatever's bigger you put in parentheses, and that would come second, and that makes the distribution easier. And that would equal the 4 multiplied by x minus 5. Distribute 6 and distribute 4 would make 6x plus 18 equals 4x minus 20. Now from here, because we have x's on both sides of the equation, we're going to have to combine like terms by moving the x's and moving the numbers. So for me, I like to keep the x's on the left side. In this case, it also, by subtracting 4x, makes the x's continue to be positive, which is a big bonus. So 6 minus 4, 2x, 18 drops down, equals negative 20, because the negative 20 would drop down. We're going to subtract 18, and we're going to get 2x is equal to negative 38. And when we divide by 2, x would equal negative 19. Okay? Next problem is going to feel like it's easier, and I would agree it's probably a little bit easier. We're going to take an x and put it over 3, and we're going to equal that to a 12 and put it over x. So when we do our cross multiplication this time, it's going to be smaller because we have less stuff, like much smaller. But it is going to involve an element that makes it a little more difficult. 3 times 12, that's not difficult at all. But x times x, you have to recognize that is not 2x. X times x is x squared. So I did my x and my x to get the x squared. And that would equal the 3 times the 12. So x squared equals 3 times 12. We got the x squared from the x times the x. Well, 3 times 12 is 36. And in order to solve this, we will have to square root both sides of the equation. So x would equal the square root of 36. Now, if you're doing just algebra, just solving an equation, when you square root, you need to include a plus or minus. A lot of times with geometry, you just write the positive version, but in algebra, you have to represent that this could also be a positive 6 or a negative 6. So I'm going to write 6 or negative 6 because 6 times 6 is 36, and negative 6 times negative 6 is also 36. So we have to represent both of them. Now, if this was a real-world application, you can't have a negative side, so that's where the negative 6 a lot of time with geometry gets eliminated, but in algebra, you need to include them both. Anytime you have an x squared, technically you should have 2 solutions. All right? We got one more problem. One more problem. For this last problem, it is also going to involve an x squared, but it's going to bring back our old friend factoring. So we're going to have x plus 2. Oh, man. That was a bad 2. X plus 2 over 3 equals 5 over x. So x plus 2 over 3 equals 5 over x. We're going to cross multiply. I'm going to have the x multiplied with the x plus 2 and the 3 multiplied with the 5. I'm putting the x on the outside because it's a little bit smaller and that makes it a little easier to distribute. Equals 3 times 5. Recognize here that this could easily become more of a FOIL situation. Imagine if this had like 2 terms here. So if that was like an x plus 8, we'd have to put this in parentheses 2 and FOIL. We're not going to have to FOIL here, but we could have very easily had to FOIL there. We got x times x, x squared. X times 2, 2x, equals 3 times 5, which is 15. Now what's different from this problem than we had the last problem is, yes, we do have an x squared, like we had in the last problem, but we also have a 2x here. This could be a 2x, a 5x, or any x really. But if you have an x squared and regular x's, you will have to factor. And in order to factor, you must first set this equal to 0. So I'm going to have to move this 15 over to set it equal to 0. So I'm subtracting 15, and I'm not going to have anything to subtract it to. It's just going to end up being a negative 15 on the other side of the equation. So we got x squared, we got 2x, we got minus 15 equals 0. Okay? Now, again, x squared and x, we're going to have to factor, and when we're factoring, we're looking for numbers that typically will multiply to that last number, but will add up to equal the middle number. So we have to think of numbers that multiply to 15, but will add up to 2. Okay? So, when we do that, we're going to end up putting in parentheses. That's what the factoring part is. So I'm going to just list out the things that I know can multiply to equal 15. I know that 1 and 15 will multiply and equal 15, but that won't add up to 2. And if I make one of them negative, still won't add up to 2. There's only one other thing. There's 3 and 5. That would multiply to equal 15 as well. And out of the 3 and 5, I do know that if I add 3 and -5 or 5 and -3, I could get a 2 in some way, shape, or form. So this add could really mean add or subtract, because if you're adding a negative, it's really just subtracting. So I'm going to end up using the 3 and the 5 in this case. I'm going to put an X here and an X there. I'm going to put the 5 here and the 3 there. It doesn't matter where you put the 3 or the 5. But it will matter which one you make negative, because in order to add to a positive 2, I will have to have a positive 5 and a negative 3 to add to a positive 2. Multiplying 5 and negative 3 does multiply to negative 15. Make sure it does multiply to negative 15, not positive 15 as well. And we factored. That's factored right there. If we're solving like we are, then we have to set each of our factors individually, x plus 5 equal to 0, each of our factors individually equal to 0, and the x minus 3 equal to 0, to solve, which really just normally changes the sign. We subtract 5 and get negative 5, and add 3, and you get your positive 3, getting our 2 solutions that were necessary. So, that is about as hard as it could ever get with cross multiplication. That's going to do it for today's episode of Math with Sohn. Till next time, have a good day, everybody. Bye.